When viewed from above, a circuit board looks a little like a cityscape. And in a way, it is. There are layers of copper roadways embedded inside the circuit board that carry electric signals. And the components on the board work like off-ramps and interchanges to direct the current. So it triggers a specific function in your computer whenever you hit a button or key. But how does it all come together so the right keystroke triggers the right function? Making a circuit board starts with covering a copper-coated fiberglass panel in film so the film can be exposed to light and developed like film from a camera. To make an image on the panel of the copper pathways that will carry electric signals through the circuit board. They use copper for the pathways because it's a good conductor of electricity. One 12 by 18-inch panel like this is big enough to print 6 identical roadways or circuits that get cut apart at the end of the process to make 6 different circuit boards. To expose the film and reveal the circuits, the panel slides into a machine that shines ultraviolet light through a template. The template allows the light to pass through only where the copper pathways will go to expose an image of the pathways onto the film. The rest of the film is masked from the light and left unexposed. The exposed film forms a protective barrier over the copper pathways, so the rest of the copper on the board can be etched away, leaving just the pathways behind. To remove the extra copper, the panel first takes a quick ride through a machine that washes away the unexposed film around the copper pathways with a shower of sodium carbonate. The chemicals don't remove the exposed film, so it's still covering the pathways when the panel comes out of the machine. A chemical bath inside a second machine eats away the extra copper. So the only copper left on the panel is the copper in the pathways. Then, this process is repeated up to 6 times with fresh panels, except each panel is printed with different pathways. Once in the circuit board, each individual pathway carries the electric current for a specific function. So when you hit a key or move your mouse, you trigger the right function. To fit all those pathways into a computer, multiple panels are stacked one on top of the other in layers to make one circuit board. The outer layer of copper foil makes it possible for still more circuits and more functions to be added after the layers are bonded together. The layers are squished together between 2 metal plates and heated in an oven to fuse the layers together. When it comes out of the oven, the board looks like a thin blank piece of copper with all the copper roadways layered inside. To carry electric signals into the various layers, up to 2,000 tiny holes are drilled in each circuit board. The holes work like portals to channel electric signals to the proper roadways. After the holes are in place, the circuit boards get their signature green color. It comes from a green solder mask that's applied with a squeegee. Once it's baked on, the mask puts a hard coating on the board to protect the copper pathways. But its primary purpose is to mask off areas of the board that should not get any solder when electrical components are soldered to the boards. The mask can be any color, but over the years, green has become the traditional choice. Once the mask is baked on, a computer-controlled machine solders on the electrical components that work like off-ramps and interchanges to channel the electric signals to the proper roadways. Then, a computer-controlled cutter cuts the large panels apart into individual circuit boards. The finished circuit boards are inspected under a high-powered microscope. And this electric superhighway is ready to channel electric signals so your computer does what you tell it to do.